Hello. In this last tutorial video about assembly, I will explain how to interact with the stack segment. Okay, stack segment is nothing more and nothing less than the memory that we have in the computer. In this case, it's somewhat simpler. Okay, we have a certain amount of addresses, right? And we can, using the memory, we can accelerate by storing information for future use. Okay, the stack, which is important also to understand, uses a first in first out system, which means that if I push a number, it will be pushed further from the beginning to the be pushed first here, and then it will start going down as long as I push more information. Let's try it. Okay, and I will put it I think I'm going to that unsigned number. You can see the value of 100 FF, well, 100, 100, yes, it's 1969, 6, and further on. So let's make a test. First of all, let me tell you that to push information to the stack, you always have to do it from a register. You cannot push their information directly. So if I want to push information to the stack, first I have to put a value in AL or BL or CL or DL or however we wanna do it. And well, let's do it. You can see that we have the stack option and push and pop. We can push, and when you do this, it will also ask you to choose a double register flag, yeah, which is eventually AX, BX, CX, or DX. Why? Because the memory, when you push the memory, it pushes two values at the same time. So if we just want to save 255, we have to put here the AH as 00. In any case, when we push it, you will see. Let's put this like this, and before we do that, let's move. Well, let's try like this. Let's execute it this way. Okay, great. We should somehow see here the representation of these two numbers here. So as you can see, number 76, number 255 started from FF. The first address did not haven't been touched, which is not the end of the world, probably because it's reserved. Okay, but as you can see, it's here. Let's try to make an orderly entrance of numbers. Let's start from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, so we can see how it enters. Okay, let's move to AL. AH, for example, the number AL, the number 1, move to AH, the number 2, move to BL, the number 3, move to BH, number 4, move to CL, number 5, move to CH, the number 6, and so on. So on. Let's say we have already 4, and we're gonna push AX. We're gonna push one after the other. We want to see together what will happen, how it will be represented in the stack CX, in the memory stack. Okay, we execute, and again we start by executing this. So first we moved all the numbers 1, 2, 3, 4, 5, 6, and now we will start pushing information into the stack segment. So you can see 1, 2, which AH enters the second, first enters AL. Okay, then we have 4, 3. Okay, it occupies from the lower to the highest, but it goes under to the lowest point. And again, so we didn't really make it to look like 1, 2, 3, 4, 5 because we didn't really know how it goes. So let's fix it. Let's put here AH, AAL, BH, MBL, CH, and CL. And again, Let's save it. Let's execute it. And now we should see it symmetrical. Okay, 1, 2, 3, 4, 5, 6. Perfect. Now the question we have to ask ourselves is what will happen when I want to take out that information from the stack? Again, when you should do pop, which is the way to take it out, we have to point to a certain, for example, register in the CPU to store that information. We're going to use the DX for that. Okay, if we do one pop to DX, we'll see how it's represented. We will see if it's the 1, 2 that comes out or the 5, 6. In theory, it should be the 1, 2 that comes out, which means that the first in, first out. Okay, but let's be sure about it. So this is the push operations, and now we're going to have the pop operation. Let's keep our eyes on the edge. As you can see, what we eventually came out first is the last information that came in, which means that it's not really a first in, first out. It's a first in, last out. Okay, which means that the first element to get into the stack will come out last. If we keep doing pop another 3 times, another 2 times, in total 3, eventually we will have the number 1 and 2 in these 2 positions. Okay, now first pop, second pop, 3 and 4, third pop, 1 and 2. Perfect. And it ends. So with all this, we completed our tutorial. Using all these elements, you can solve simple logical problems that you'll be exposed to. And great. Let's hope for in the future to make a more complex assembly combined with C++ tutorial. I let me remind you that assembly can be combined with C and C++ for more powerful programming algorithms. And well, maybe in the future we'll make more tutorials about that. So goodbye.